Let's see. As in order, we are initiating the code and we're not going away.
Where's DNA replication? Let's see. So for DNA replication, the helicase enzyme is going to unzip the genetic code. As the DNA is being unzipped, the leading strand is going to be building the complementary nucleotide base pairs. That's going to happen continuously. As the DNA is unzipped, this side of the leading strand is being built.
Miss Connor,
What are you doing here?
I don't know. Let me head back to DNA replication.
On the opposite side, the lagging strand. First, a primer is going to
be laid down by the primase enzyme, which is where the DNA polymerase should begin. And that is then where those complementary base pairs are going to start and be built.
No, sorry. Guess I just keep getting lost. Back to DNA replication I go.
The next section is going to have a primase lay down a primer. That indicates the polymerase is going to build the next section. These sections of nucleotides that are being built by the polymerase are called a Okazaki fragment.
What am I doing in a closet? Let me go back again to DNA replication. Lock the door first.
To connect the Okazaki, you have a ligase enzyme which is going to replace the primer with the actual nucleotide that should go there. So you have an entire sequence. In the end, you will end up with two identical DNA, identical to the original and identical to each other. During protein synthesis, first, the helicase enzyme is going to unzip the DNA. The DNA is going to go to the RNA polymerase. The RNA polymerase is going to match up the mRNA pieces and start to build an mRNA chain. This side is your non-coding strand, your template that actually matches with the mRNA. The other side is your coding strand, which is actually what is built. It's A, U, G, C. The only difference is that instead of T, you have U's for mRNA. Part of the mRNA is useless stuff. Those are called introns that have to stay inside of the nucleus because this is taking place in the nucleus. And the useful ones are going to be exons that are allowed to exit or leave the nucleus. The mRNA is going to go to the ribosome and rRNA. That mRNA is going to be translated. You have arrive, place, and exit spots on your RNA. These three sections of your mRNA are codon. The codon is going to match up with a tRNA's anticodon. tRNA arrives. It's going to actually connect and be placed here. Once the connection is made, the amino acid is going to be released.
I'm not gonna lie, because we got. This process is going to continue on where you have amino acids that are going to start connecting together, and you have tRNAs that are going to be leaving.
And this is all for
on the video, she has it there. Because that's how she had it in the video. Can you see? Okay, let's just bring it. Oh, genetic codes? Yeah. They probably get it out. So it's that we take here. What's the connection
Okay.
When those tRNAs leave, they are recyclable. So they're going to pick up another amino acid and bring it back. And the amino acids are going to be chained up, continuing to be chained up again and again. until a stop codon comes along. The stop codon is going to cut off your amino acid chain, which is now going to be curling up into a polypeptide that is going to be showing up as a particular gene expression. The entire process is the central dogma. Central dogma says that you go from DNA to RNA to protein.
Oh my god! I'm floating! I'm floating!
Yeah. Okay, love you guys. Don't forget to smile.
We